Okay, so let's just see. We have covered single phase rectifier circuits. Let's just see some three phase rectifier circuits, right? So first circuit that we are going to talk about is actually a three phase and a three pulse rectifier circuit. We already saw what was a two pulse, right? A full bridge rectifier circuit was a two pulse because the output voltage had two pulses in it. So what is a three pulse circuit? So if you consider an three phase source, right, wherein you have VN, VBN, VCN, right, and connect three diodes and connect them to a common load. This is nothing but one of the three phase rectifier circuit, which is also called as a three pulse circuit. So let's I mean, you can obviously have any kinds of load. You can have R load, you can have L load, you can have RE load, you can have RLE load, and so on, right? Let's assume that the load has an inductor. So it either falls, it could be a pure L, it could be L plus R, it could be L plus E, or it could be LER, whatever, right? It could be any of these forms. But then it has a large value of inductor. So it could have small value, but let's just for analysis assume that it has a large L. Essentially, what does that mean? That means that this current is almost pure DC, right? It has negligible ripple. So now if you see among diode DA, DB and DC, right, let us try to understand where this current will flow from, what is going to be the voltage output VO. So first let us draw the three phase voltage waveforms. All right, let me approximately draw it. So let's assume that the phase sequence is A, B, C. That means phase A is leading, followed by phase B, followed by phase C. So this completes the full 360 degrees. This is 30, 60, 120, 90, say 30, 60, 90, 120, 150, 180, right? And then again 360 at this point, right? So this is VAN. So this is your complete power cycle. Now we have assumed large value of inductor. That means the inductor current is continuous, right, and almost ripple free. Therefore the current has to, one of these three diode must always conduct, either DA, DB or DC, right? So the only thing that is left is we need to figure out which diode will conduct in which duration. So these are in common cathode configuration, right? So the diode with the highest anode potential will conduct. So now it becomes straightforward. If you see from 0 to 30 degrees, which diode will conduct? The one which has the highest positive voltage, which is VC. So DC will conduct. Then during this period, DA will conduct. During this period, DB will conduct. And again during this period, DC will conduct, which will continue conducting into the next cycle, right? What about the output voltage waveform? If you see the output voltage waveform, if DA is conducting, output VO is equal to VAN, then VO is equal to VCN. If DC is conducting, DA is conducting, it is VAN, VBN, and then again VCN, right? So you see how many pulses does the output voltage has now? It has 1 bottom, 2 bottom, 3 bottom. So it's a 3 pulse circuit, right? So therefore the name goes as a 3 pulse circuit. And now you see that the output voltage in 2 pulse case, it was coming to 0 and then again going up. Here it's not even touching 0, right? So the ripple is small, delta V is small, so you would get even better quality output current with the same inductance that you would have used previously, and now you will get even smaller current ripple. Why? Because the output voltage ripple is also small. Alright, now one more thing which you should observe in this circuit is about the input current. So how does the input current look like? Let's say let me draw only IA, right? So how would IA look like? It is 0 except when diode D is conducting. At that time it becomes equal to I, and I'm assuming I to be constant. So therefore this is how my IA would actually look like, right? And this would repeat. So the problem of half wave rectifier, which was an input DC bias, also exists here. And more so if you see, 3-phase circuits are generally used for high power application, and in high power you would not want to draw high amount of DC current from the input, and therefore this circuit, although it's good for the understanding, is you would never see it being used in practical applications because of this limitation. Right, so now what we'll do next is we are going to talk about another circuit which is also a 3-phase circuit, but which has an input current which is AC, pure AC, and which does not have a DC component.